Hello, everyone. Today's joke of the day is what goes up and down but does not move. Stay tuned to find out. Our learning target for today is I can write a function to model arithmetic sequences. So yesterday we learned a little bit about what arithmetic sequences are, okay, and how to determine the common difference and the zero term, and then a few more terms right after that. Okay, just to remind ourselves, arithmetic sequences are sequences that add by the same number every time, or subtract, right? Same thing. Okay, well, arithmetic sequences can be modeled by this function here. We have f of x equals mx plus b, okay? This might be something that you have seen before, or sometimes you'll see it as like y equals mx plus b, okay? That would just be like a normal, linear equation, right? This is what we call function notation, okay? And when we're modeling an arithmetic sequence in function notation, this m, right, this one here, the m is called our common difference, and this b here is going to be our zero term, okay? So we'll look at our sequence, we'll figure out our common difference and our zero term, and then we'll substitute those numbers into our equation for m and b, okay? So let's try a couple examples. Given the following arithmetic sequences, write an equation to model them, okay? So if we have 5, 8, 11, 14, 17, okay, well, looks like we're going up by 3 each time, right? We're adding 3. So that means that our common difference, which now I'm going to call m, is equal to 3, okay? Well, and if we're thinking about what our zero term is, right? This 5 is our first term, and then we have 2, 3, 4, 5. Those are all of our terms, right? So if we have our zero term, it's the term that comes before that 5. Okay, well, we can think like what plus 3 is going to give us 5? Or we can do the opposite, just subtract 3 from 5, and we should go back to 2. So 2 is going to be our zero term. So if we look back up at our function notation, okay, we have f of x equals mx plus b. Okay, we want to substitute in, we'll keep our f of x, this is going to be our function. We'll substitute in 3 for m because that's our common difference. We'll keep the x. And then we want to add 2 because that's our zero term. Okay? So this is going to be our function to model an arithmetic sequence. And we'll talk in a little bit about why we might want to do something like that. Okay, for this next one, this 20 is supposed to be an 18. It was just a little typo in there. Okay, but if we have 18 to 16, 14, 12, okay, our common difference is going to be negative 2. Right? It looks like we're subtracting by 2 every time. So m is equal to negative 2. Then if we want to find our zero term, okay, we can think, okay, what minus 2 is going to give us 18? Or we can just add 2, right, to 18. Work backwards that way, and we should get that our zero term is 20. So when we write our equation, we have f of x is equal to negative 2x, oh, there you go, plus 20. Okay, and that's our equation for this, that's our function for this arithmetic sequence. Okay, let's look at one more. We have 26 to negative 26 to negative 21. Well, that's adding 5. Okay, and it looks like all of the other ones are like that too. So our common difference is going to be 5. Our zero term, our b, okay, what plus 5 is going to give us negative 26, or we can work backwards. Negative 26 minus 5 should give us negative 31. So our function will be f of x equals 5x minus 31. Okay? Now we can use this equation once we've written it to determine any given term. Okay? So let's look at these arithmetic sequences, write a function to model them, and then we can determine the given term number. Okay? So just like we were doing on the previous page, we have negative 17 to negative 22. Okay, well, I'm subtracting 5. So we know that our common difference is equal to negative 5. Okay, and then our 0 term is going to be, okay, what minus 5 gives us negative 17, or negative 17 plus 5? Well, that will be negative 12. So our function is going to be f of x equals negative 5x minus 12. Okay. Now we can use this to find the 50th term in our sequence. Okay. Our 50th term is going to be whatever we end up with when we substitute 50 in for x. Okay, so if we want to look at f of 50 is equal to, okay, now we're going to substitute a 50 in wherever there's an x in our function. So we have negative 5 times 50 minus 12. At this point, I will just use my calculator to tell me that f of 50, okay, we'll just do that. Negative 5 times 50 minus 12, that gives us negative 262. Okay, so our 50th term in our sequence is equal to negative 262. I'm going to leave this f of 50 part in here, right? This part right here that I'm going to highlight quick, because this tells me that the 50th term in my sequence, right, that 50 tells me it's the 50th term, is equal to negative 262. Okay, let's look at this next one. 3, 9, and 15. Well, our common difference is going to be plus 6, right? So our m is equal to 6, And then if we subtract 6, or think what plus 6 gives us 3, we'll know that our 0 term is equal to negative 3. So our function here is f of x equals 6x minus 3. If we want to find the 95th term, then we can substitute that into our function. So we have f of 95 is equal to 6 times 95 minus 3. And again, I plug that into my calculator to get that f of 95 is equal to 567. Okay, and there's my answer there. That's our 95th term in our sequence. Okay, finally, let's look at this last one. We want to find the 500th term in this sequence. So you have to start by finding the common difference. Well, it looks like I'm adding 12 from negative 4 to 8. Okay, and we know that m is equal to 12. Okay, our 0 term, okay, what plus 12 is going to give us negative 4? We can take negative 4 minus 12. That will give us negative 16. So our function is going to be f of x equals 12x minus 16. And now we want to find our 500th term in our sequence. That seems like it would be really challenging, right? Because you don't want to write out 500 terms, right? But if we just use our function, we can see that f of 500 is going to be equal to 12 times 500 minus 16. And now that's super easy to plug into our calculator. So we get f of 500, our 500th term in our sequence, is going to be 5,984. Okay, I know you're all on your edge of their seats for this one. What goes up and down but does not move? Well, it's a staircase. Thanks for watching and have a great day.